Welcome to the another video of the power quality here. In this video, the question is asked like three-phase unbalanced supply system is given in terms of per unit. Usually, if it is a balanced, VA is 1, VB is 1, VC is 1, and the angle is 0, 240 degree and 120 degrees. So if I draw this VA here, like this is the VA and the angle is 0 degree and the angle is taken in anti-clockwise, so VB is 1.05, 240 degrees. 240 degrees is over here, so this is 240 degrees VB. The angle is 240 degree and the VC is 0.95, 120 degree. So VC is 0.95, 120 degrees, so it is 120 degree. So if I seems understood that this is the dotted line which is 1, so VA is 0.9, so VA is somewhere up to here, and this is VA. VA is 0.9 angle 0 degrees and VB is 1.05, so VB is little bit of more than that, and this is VB is 1.05 angle 240 degree and VC is 0.95, so a little bit of lesser than that, 95% we can say. Lesser than that, and this is the VC is 0.95 angle 120 degree. Now if this is a VA, VB, VC are unbalanced, right? And the question is asked that find out the positive, negative and zero sequence component of this voltage. What is this positive, negative, zero sequence component? Let me tell you that any three-phase voltage can be resolved into a positive sequence, where the positive sequence is this VA and VB will be here and VC will be here. So when this motion is in the anti-clockwise, VA, VB and VC, it's come like this. First VA, then VB, then VC. It's a positive sequence. And the negative sequence will be, VA will be here and the VB will not be left. Then if the motion is in the same direction, if we consider the motion in the same direction, then this will be VC and here will be VB. That means first VA will come, then VC will come, then VB will come. That is that negative sequence. You can also understand the negative sequence as if the same thing. If I can redraw this, similarly here VA and here VC and here VB, but if I reverse the motion here in the opposite direction, here it is in the positive anti-clockwise, here it is in clockwise, so first comes A, then comes C, then comes B, so it is a negative sequence. In anti-clockwise, if it is anti-clockwise, A comes first, then B comes first, second, then C. This is a positive sequence. If I keep this motion in the anti-clockwise in both the case and I redraw it like VA, then VC over here and VB over here, then it is also a negative sequence. And when I say zero sequence, here VA and VB and VC all will be in the same line. And also let me remove this just for the sake of clarity. So now we have got a positive sequence plus negative sequence plus zero sequence. what does it mean is the positive sequence A, B, C are all equal. VA is equal to VB is equal to VC, the magnitudes are equal. In negative sequence also the magnitudes are equal. Zero sequence the magnitude are equal. Only here the angle A is with 0 degree and B is with 240 degree. However, in negative sequence B is at 120 degrees. And in the zero sequence B is at 0 degree. And in positive sequence like C is at 120 degree, in negative sequence the C is at 240 degree, and in zero sequence the C is at 0 degrees. So if we take the VA, it is here, I can say the VA, this is the original one, is a sum of the positive sequence, negative sequence and the zero sequence. If this is perfectly balanced, like VA is equal to 1, the positive sequence this will be 1 and the negative sequence will be 0 and zero sequence will be 0. However, in this particular example, what we are going to learn is if the magnitudes are made unbalanced, like VA, VB, VC, they are not equal, will there be any negative sequence or will there be any zero sequence? If yes or not, that we will see. So what we can get the formula out of this is that we can say that VA is equal to, let us say, give a nomenclature like a positive sequence as 1, VB1, VC1, and negative sequence as 2, 2 and 2, and zero sequence as 0, 0 and 0. So then I can write VA is equal to VA1 plus VB1 plus, VA1 plus VA2 plus VA0. Similarly, we can write VB is equal to VB1 plus VB2 plus VB0. And VC is equal to VC1 plus VC2 and VC0. What other information that we have is that the VB0 and VC0 is equal to VA0. We can replace it, we can have a substitution over here. And what we can substitute over here for VB2? So VB2, we can say that VB2 is equal to A times VA2, and VC2 we can say that it is A square times VA2, because A, what is A means? A is what? A is e to the power j 120 degrees, or rotating it in anti-clockwise for 120 degree. We get a value of VB2 if we rotate VA2 by an angle of 120 degree. That is why VA2 is equal to A times of VB2 is A times of VA2. We rotate VA2 by 240 degree, and then we can write VC2 is equal to A square times of VA2. In positive sequence, we can write here VB1 is A square times, right? Because VA need to rotate A square times of VA1. And VC1 is equal to, this is just 120 rotation, so A times of VA1. If I substitute all those values, we can write this as same VA1 here plus, that means, let me write here nicely. We can write here VA is equal to VA1 plus VA, let me write 0 first. VA0 plus VA1 plus VA2. And I can write VB is equal to, VB0 is same as VA0, so let me write here VA0. VB1 is, this is for VB1. VB1 is A square times of VA1. So A square VA1. and VB2 is a negative sequence voltage, which is A times of VA2. So A times of VA2. Also we can write similarly VC is equal to VC1. What is VC1 is here A times of VA1. So A times, okay, first VC0. VC0 is same as VA0. VC0 is same as VA0. Then VC1. VC1 is A times of VA1, and VC2 is A square times of VA2, and that we can again rewrite as in a matrix form 1 1 1 1 A square A 1 A square, this, and we can write here as VA0, VA1 and VA2. So what we can get a picture is that we can write this VA, VB, VC, this is the any three-phase voltage as a sum of the positive for sum of the zero, positive and negative component. And now we can also write ABC as only if I know, suppose if I know only A phase zero component, A phase positive sequence component and A phase negative sequence component, then it is possible that we can determine what is VA, what is VB, what is VC. That's it is clear from this expression. So if this is a matrix, so also we can get what is VA0, VA1 and VA2 in terms of ABC, just doing the inverse of it. And if we do the inverse of it, what we are going to get? We are going to get VA0, VA1, VA2. We can also get by taking the inverse of it, that it will be 1 1 1 1 by 3 first. 1 is, this will be A. So we will be getting VA0, VA1, VA2 from VA, from VB and VC. If the like three things are given, we can get the positives, negative, positive, zero, positive and negative sequence out of it. So we have got two formula over here. One is VA, VB, VC, which is equal to 1 1 1 1 A square A 1 A square. This is into VA0, VA1 and VA2. The objective of keeping this only one sequence, if I know zero sequence and positive sequence and negative sequence, then automatically we can get the other, like if I know VA1, VA2 and VA0, so we can calculate the other values. The good thing about this sequence is that positive sequence, negative sequence and zero sequence, that these are balanced, like VA1, VB1, VC1 equal. And they are like negative sequence also, they are equal, but the phase sequence is different. Zero sequence, there is no phase sequence, there is a phase sequence is 0 0 0 all, but the magnitude is equal. All are sinusoidal. Thing is that here how the B is lagging, here how the B is lagging over here, and here B is not lagging, he is in phase with VA. So in case the three-phase supply voltage is equal, we will have only positive sequence. But if there is an unbalance, apart from positive sequence, we'll have negative sequence and zero sequence, which is very dangerous. Because this negative sequence and zero sequence will not be helping us for giving a proper torque to the induction motor or fruitful work. Negative sequence is going to give a distortion, zero sequence is also going to give nothing. So these are giving a lot of losses in the system. So coming to our problem is, now if we put the value of VA, VB, VC here, so we can evaluate. I would like to write all those things here. So like if I write here VA0 is 1 by 3 times of VA, that is 0.9 angle 0 degree plus VB 1.05 angle 240 plus VC 0.95 angle 120. We can get the cosine component and the sine component of this and divide by 1 by 3, and what we are going to get is minus 0.033 minus 0.0 in J 0.0288. This gives me the polar form as this 221.1 degree. And I can rewrite this as 0.043238, an angle of minus 138.9 degree by just subtracting it with 360 degree. So this is how we get the value of VA0. And VA1 will be obviously this, let me write here, VA value is 0.9 angle 0 and VB A into VB, right? So what is the value of A is nothing but 1 angle 120 into 1.05 angle 240 plus A square. A square is nothing but 1 angle 240 into 0.95 angle 120, and this is, if we solve it, we will be going to get is 0.966 angle 0 degree. VA2 will be equals to 0.9 angle 0, the value of VA, plus A square, here it will be 1 angle 240 into 1.05 angle 240, 1 angle 120 because A is multiplied with the VC, 0.95 angle 120. So this gives me the values nearly 0.0438 angle 138.8 degrees. So here I am getting the VA0, 0 sequence, VA1, this is a 0 sequence component, VA1, this is what this is what the good 0.966 VA1. And the negative sequence component, this is in terms of per unit all. So these are all the negative sequence, this is a problem. And the 0 sequence, this is again going to be a problem. So this 0 sequence, positive sequence, it is good, 0.966. And because of this unbalance, we are getting a 0 sequence and a negative sequence. So this is going to be a problem in the supply system. So that is why we need to keep this 3-phase voltages equal, and if there is an unbalance, that leads to the 0 sequence component of the current. This is 0 sequence component of the current and the negative sequence component of the here the voltage. So 0 sequence voltage and the negative sequence voltage is there. And all these things that we discussed is to elaborate that unbalanced voltage can leads to positive sequence, apart from positive sequence, negative sequence and 0 sequence voltages. And this 0 sequence voltage will lead to 0 sequence voltage will lead to 0 sequence current, and the negative sequence voltage will also lead to negative sequence current. So that will all going to degrade the quality of the output. So if we want to maintain a very good quality, so these 3 voltages need to be equal and the angle need to be displaced from each other by an angle of 120 degree. So thank you very much. In the next videos we are coming with another problem. Thank you again.